Alright guys, we're back with part 2 of the build assembly series on the Lanyu Hobby Volantex RC ASW-28 version 2, which is also my version 2. This will be the second one I built. We're ignoring the instructions. We're going to just jump right into the electronics so we can get the electronics fired up. We're going to be replacing the ESC right off the bat. ESC is fine, but not necessarily fine for this application because I am going to be using a stabilizer, Lemon RX 7-channel with stabilization, and I'll be using a little bit larger prop and potentially going up to a 4S at some point. This is the pack I used at the end of life on my last one, but I'm going to stick to 3S for now. 60C 2200 3S Turnigy heavy duty. So that's my initial plans. This plane is fairly tight. Once the rods go in to connect the wings together, you can fit a 2200 milliamp pack up here, and that's hunky-dory, except you got to keep in mind that all those wires have to go underneath your rods. So just be thinking about that. And the other thing is this narrows as it goes back, so it does a nice job of holding it. But then you also have to keep in mind that you got Patrick here that's got to plop in here. So you're going to want to be careful about that if you want to go ahead and use the scale pilot and the scale detail there. Now, I will probably go ahead and use it, but for now, what we're going to do is we're going to set up and bench test to figure out which ESC we're going with, and I'll hopefully be able to demonstrate for you the problem with a stock ESC and its timing woes. Now, like I said, it's fine for a small foamy or something like that, but I want a little more reliability. Okay, so real quick, radio setup, we're going to be using a Spectrum DX18. This is a Gen 1. Gen 2 should be real similar setup, and it's actually real similar to most of my models, regardless of the fact that it is going to be a sailplane. So, without further ado, this is my old setup was a 10-channel, and it was a glider, and I had a stabilizer also, and then later, after I had a massive failure, then I switched to a Lemon RX 7-channel with stabilization from the 10-channel that had a satellite that was pulled way back here and ended up crashing it again. And what I found out was I believe the BEC on my electronic speed control had issues. So anyway, what I'm going to do is I'm going to go back to system setup. I'm going to go to model select, scroll all the way down to the bottom of the list, and I'm going to add a new model. I'm going to create the new model. We're not going to get all this set up now, but we're going to get it set up enough to do this test. So model name, see how it says sail? It's kind of interesting. Sailplane type. You can do all sorts of things, but this isn't going to be a sailplane. It's going to be an acro. Confirm it. That resets all the parameters. And we're going to change this to ASW-28, so I'll pause it and then come back when that's done. Okay, so we got the name in there. So now we can just hit back. Aircraft type. I'm going to change this to a picture of a glider. I'm just going to show a powered glider with a high T-tail. Okay, cool. And we'll change this to I'm torn. It's either going to be set up as flaperons or it's going to be set up as one aileron. We may set it up as 2 ailerons and 1 flap. Or we'll set it up as flaperons. Usually I just set it up as flaperons and then I mix in the flaps because I want to do crow, where the outboard, the ailerons go up together and then the flaps go down, and that helps to bring the plane down quick. The tail's normal. We'll try that first. I'm not going to do any settings here. So then channel assign. Gear switch is definitely not going to be set to flap. That's kind of weird. I don't know why it would be set that way. Where is gear? Let me figure this out. I'll be right back. Okay, so I figured out why it's doing this. Because I set it to 2 ailerons instead of flaperons, like I would normally do. It's automatically assigned aileron to right aileron, and then auxiliary 1 to left aileron, which I'm okay with. I don't have any problem with that. Except in thinking about the way that this Lemon RX is set up, I'm actually going to probably go to aircraft type and set it to flaperons. Okay, and I'll show you why later. Okay, so then we'll go into channel assign, and we should see that gear is gear. Now this is important because the gear channel in our case turns the stabilizer on or off. Okay, then auxiliary 3 is our master gain. We'll assign auxiliary 3 and we'll assign the gear just to this, and then this will be our 3 different flap modes. And then I'll probably have like crow on or off, and then like regular flight, takeoff flight, or takeoff and landing, and then crow engaged would be normal still, then takeoff and landing with crow. Of course, there's not really takeoff and landing with crow, but what I do is as I'm coming in for my final, I'll fly it in with crow on, and then I can flip crow off and stay into the flaps, or I can be at like the maximum crow setting where they're just really down, and then I can quickly toggle it off and on to keep from smacking into the ground hard. So anyway, you'll see it when it flies. But for now, you'll notice the only thing that changed here when I went from flaperons to 2 ailerons and 1 flap is that it no longer automatically assigned things the way that it wanted to. I mean, you can change it. It's just nice to know that you've got it set up right. So then, gear is not going to be set to the A switch, which is up here. It's going to be set to the D switch, okay? Auxiliary 3 is going to be set to this. And auxiliary 4 and 5 we're not using, so I'm going to inhibit them to be on the safe side. Now, sliders on the DX18 would be auxiliary 4 and 5 by default. Okay, so as you can see, we got a little thing, got a timer. The first thing we're going to set up is throttle cut for safety. I always turn it on to this switch, which is switch H in our case. Okay, it goes to -130 by default, set it to -100. Okay, verify the throttle stick is up. You'll notice the throttle's not moving. This is the position I want to be safe. Why do I pick this position? Because if somebody bumps it, I think it's more likely to get bumped this way than it is to get bumped that way. I don't know, it's just in my head. So throttle's working, throttle stops working. Okay, perfect. So throttle cut is on. Second thing we'll set up, flap system, set it to B. We're not going to mess with any of the settings yet. Because this is actually going to be flaperons, it's going to be our outboard aileron setting, and we'll fiddle with that. It gets a little complicated when you're doing flaps and crow. Then mixing, we'll mix that in later. Timer, we could, since this is a powered glider, we could set, rather than doing a 1-out timer, we could set it for throttle on, kind of like a helicopter would be. So like when the helicopter's spinning, you want to consume a lot of power, so you start it when it's up and you shut it off when it's down below a certain percentage. That's what this 25% is here. In our case, I'm just going to do a 1-out because that's what I do tone and vibrate on ours. On DX18 Gen 2, you would have the option for voices, and you can have all sorts of different prompts. Okay, so timeout is 1 time is inhibited. I want to make it active. That means when I move the stick up, it automatically starts, provided I reach 26% or greater. Okay, and you can lower this 26 down. You can also set other buttons to do things. One of these days I'm going to figure out a button that's going to pause the timer, because it's nice when you land you can pause it and then you can pick it back up when you launch back up in the air. But I'm probably going to set the timer to like, we'll say like 8 minutes. We'll just set it to 8 minutes for now. And then what we'll do is we'll get our maiden in, we'll see how the battery performs, and then we'll go ahead and adjust accordingly. The other thing I'll do real quick, a differential and expo. I set all my differential and expos, dual rates and expo. That's a bad habit I learned when I was first doing this. This is dual rates and expo. I always set them to F. I always set all my radios the same as much as I can. Occasionally I'll have different switches based on landing gear or not. But it's good because your brain doesn't have to refigure where everything is on each model. Okay, so elevator, turning it on to switch F. Rudder on to switch F. Okay. The lowest setting for rudder is going to be 10, then it's going to go to 20, and it's going to go to 30. Now I usually start it kind of like this sort of default range. I can tell you right now I already sort of know how this plane performs, so I wouldn't need a lot of expo, but sometimes one plane to the next there might be a little bit of a change in performance. So I'm going to set the elevator to 10. This just gives us a little bit softer response from the sticks. And the stabilizer is going to exemplify, it's going to amplify any sort of effect similarly. Expo and stabilizer have a similar looking effect when you're flying, and it deadens the sticks to a degree. And I know that sounds overly simplified to those of you who know better. Just stick with it for now because I'm trying to help out the new people. On the top setting, all the way down, there's 0, 1, and 2, okay? I want to have a little bit less for a rate, meaning the stick's pulled all the way back, it's only going to go, the elevator's only going to go up 90%, okay? So, and I'm going to explain this in a second. So ailerons, if you've seen any of my videos, you'll know how I do this. The initial setting is the lowest, then a middle setting, which is what I'm going to start with, and the top setting is even more strong. And what that does for me is when I get up for my maiden, I start in the middle setting. I get flying, things don't seem good, I need a little bit more dampening, I'll click it down one click, and then I'll adjust when I'm on the ground to make the middle setting what the top setting had been. If not, then I go to the lower setting if I need more sensitivity. And then when I land, I set the middle setting to the top setting, and so on and so forth, and I halve and double. So what that does is it gives me this immediacy to the controls. Okay, cool. Back to the point. Next step is to get this cut out. We'll do that next. Okay, so we can power off the radio. Got some sharp scissors here. These guys are all concerned about, you know, like saving the world by using less packaging. I have a sneaky suspicion that they're just trying to save a buck on shipping. But you know what? I'm all for it. If you can save a buck on shipping and, you know, pretend to save planets, that's fine with me. I don't care. Just save the planet all you want. The good news is it is pretty cheap for shipping. The bad news is I've had a couple of these with cases that have been chipped, and particularly around the antenna here I've had a couple that have come with some dings, but never had a receiver that hadn't worked. So that's good. Comes with a double-sided piece of tape, like a little 3M foam tape, and that's supposed to help avoid picking up some of the vibration from the plane, so that's super nice. Okay, so we're going to immediately stick the bind plug on here. Now I told you I'd try to demonstrate the, forgive the terminology, but the fart on this factory setup for the electronic speed control and power. Okay, so what we'll do is signal goes up, ground goes down. You can see that from the drawing, and Lemon's good about this. They mark signal, plus, and minus, okay? But since this is an end pin, you know, you have to chase them over and then down, right? Okay, so we'll stick this into the throttle channel here, which is clearly labeled right there. It says throt. This one says bind, okay? And then we got our 2200 milliamp 3S pack. You wouldn't have to strap this in. I'm just going to do it in that position because it's easy. And then I've got this little voltage alarm. We'll link to those. These things are just lifesavers. I use these on every application where I can fit them, or when I don't have a CG issue as a result. I've never really had that except for the UMX planes. UMX planes just can't handle the extra weight. And I mark the front minus and plus because I always got to flip it upside down to see where the polarity is. Because this is a 1 through 8S, and then I cover this up with my finger so it doesn't blast my eardrums. Okay, so we'll let that sit there. You'll notice it comes with an XD60, which is super nice. Okay, so we're going to go ahead and power on the receiver. Or actually, we're not, because we have to bind it first. Throttle cut is on. Stick is down. Sticks are neutral. Where we want them, our neutral position. There isn't fail-safe on this particular setup, but some of the Lemon gear does have fail-safe now. So you'll want to be aware of your stick position on the initial bind, because where your sticks are is the fail-safe position. Don't mark my words on that. Some of these do have different procedures. Okay, so we got everything plugged in, meaning everything as in the ESC and the motor. and the receiver. So we'll go ahead and plug this to this. I always double check colors quick. Okay, we're flashing, so we're in bind mode. Get yourself at least about a meter or so away. I'm going to hold the bind switch, then I'm going to put this up. You can see the flashy light's going to slow down here. It says binding, DSMX 22 milliseconds. Okay, so you hear that noise? Cool. So now we're going to, throttle cut is on. We're going to test it. Motor's not spinning. That's good. Okay. Okay, throttle cut's back on and tested. Now, you can see there's a pretty good amount of torque on that thing. First thing I want to do, unplug your bind plug, lay it aside, unplug your battery, reboot. Throttle cut, stick, reboot. Now you don't have to do that step, that's just a step I do out of pretense to help build good habits. If something is weird about the way that this initiated because of the binder coming out of bind mode, then that'll be satisfied by rebooting. Okay, and it takes 1 second, so just do it. Alright, so now what we're going to do is we're going to go ahead and throw the prop on here for a test. Everybody always says to do this without props on. Well, that's fine if you're not concerned about testing stuff with the prop. Well, we are in this case. Okay. So now we're not even concerned about the stabilizer at this point. So all I'm going to do is I'm basically just going to drop that in sort of loose, just making sure we aren't going to hit the motor. And we won't, because it can't even get that far. And then we can go ahead and plop on our canopy. See how this canopy works? It's got those pins that drop in there. Real simple. And honestly, I'm sort of tempted to leave Patrick out of this equation just for CG reasons, but I think we'll put him in there because it looks really cool. And you can definitely see him when he's flying by. So it looks pretty cool. So the way this works is you got to have a Phillips screwdriver. You undo those 2 screws, this pops apart. Okay, so I got some screwdrivers and tools lined up so we can get all this stuff done. So basically you just undo these 2 screws, then that's going to give you access to take the spinner off. Once the spinner's off, it's a compression fitting. Okay, this compression, when this is pulled tight, it squeezes the shaft of the motor. Okay, so since we're not super concerned with the looks at this particular juncture, so we're just going to lay that off to the side. And what I'm trying to demonstrate is this noise that the ESC will make. I just use a crescent wrench on stuff like this because there's metric and standard parts throughout, and it's, well, I mean, most of the parts on this are metric. So we got that nice and tight. Let's make sure it doesn't want to pull off, and it doesn't. Okay, cool. So now we can go ahead and test this. So we're just going to hold it this time. Throttle cut's off. Make sure it goes the right direction first. You can tell. Okay, throttle cut's on. Now, what do you guys notice about that that's really dumb, being that this is a sailplane? If you don't notice it, you don't fly sailplanes. What it is that there's no braking, and that's ridiculous. Okay, you need braking. You have to immediately have braking. Okay, now I don't know if the braking causes some of this issue, but we're going to go ahead and turn it on right now. Okay, throttle cut's on. You want to go ahead and unplug your battery to do this safely. Throttle cut's off. Stick is all the way up. All the way up. Throttle. Okay. You'll notice what's going to happen is it's going to beep when I plug this in. Down. Okay. Throttle cut's off. Okay, so we didn't get all the way into the menu. And I got a video on this. I'll link to it. Throttle cut's back off. Sticks all the way up. This is where you got to be careful. Sticks all the way up, and you're detached. That means when it starts, it's going to go into setup mode, okay? You can use a programming card too here. Down. See, it didn't do the burp, burp. There's your brake. See how it... Okay, if you have braking, this thing will operate 100 times better. Okay? And fortunately for me, I don't have the issue that I have experienced That's awesome. Okay, so no timing issue. Now it just becomes a function of a larger BEC in this case. That's great news, guys. Maybe they've fixed the electronic speed control. Okay, so we're going to unplug the battery. Throttle 6 down, throttle cuts on. We're going to grab the load tester. We're just going to see what we get for a load on this initially. Plug that into the electronic speed control, and then plug our LiPo in here. This is going to be the same LiPo for both tests. Okay. We're just going to hang that over the edge, make sure we have plenty of room. Remember, when you bench test a plane, it's going to be a slightly different condition than when you're flying, because unless you're coming out of a stall and trying to recover, you're never going to really be that much more load than from stationary, statically sitting still, and then trying to pull out of it, okay? So, we're going to go ahead, throttle cuts off, bring it up. Full throttle. This looks like about 15 amps full throttle. 15.48 amps, or about 165 watts. Okay? Throttle cuts on and tested. Alright, so now, what that tells me is that a 30 amp ESC will be fine. But let's go ahead and, just for fun, let's go ahead and throw this larger prop on here. For those of you, I've closed my door with the wind. That's always exciting. I looked back and I thought, well, Casper's back. Okay, so we'll break that nut free, thusly reducing the amount of grab on the shaft there. Then we should be able to get this off of there. Sometimes they don't like to come off, but this one did. Good. Now we're going to take this larger prop, which is a 12/7, meaning 12 inches and then 7 inches of angle. It's supposed to be 7 inches of forward progress at so many RPMs. I'm not sure exactly what I think of is, I kind of wish it wasn't 7 inches. I wish it was some sort of an absolute value. A value that would be indifferent to unit of measure. Okay? But it's not. So they didn't ask my opinion on that one. Okay, so we've got that tightish. Let's double check it's all the way tight and safe. Okay, now this is going to load the motor a lot more. Okay? Okay, so peak amps was 15.48. Okay? Alright, throttle cuts off. We'll take it easy this time. Oh, it feels like we're rubbing somewhere. Oh yeah, we got it back a little bit too far. That was an oops. So all we've got to do is, feels like we're hitting, but I don't think we actually are. Are we hitting? Yeah, we're hitting one of the screws. One of the 4 screws. Throttle cuts on, tested. We're just going to redo that real quick and pull it out just a little bit. Okay, so I got that reseated. I just pulled it out like half of a millimeter. Alright, so I've got my meter here again. Throttle cuts off, just holding that so it's away from the countertop here. So 26.44 amps of maximum current, and that's reasonable. Now let's go ahead and give it a slow increase. Okay, so it looks like we're pretty decent here. How many watts? About 262 watts. Throttle cut's on. So now, one other thing you can do is you can test for temperature on the ESC and on the battery. And based on the performance of that right there, we're well within the specs of the Volantex RC ESC. But I can tell you right now that, you know, it's probably a little bit on the close side for me. I would like to have a little bit more extra. But this actually has a separate power circuit for the S-back. And so that protects us from losing all the rest of the controls. Okay. So anyway, that's where we're going to go. We're probably going to go ahead and get the ends onto this and move on to that for the next step. We'll pause it for that. Actually, I was just realizing, if you guys were doing this, you could just stick with the stock stuff and you'd probably be fine. But if you insist on using a stabilizer like me, then you probably want to go a little bit more higher quality for the ESC. But if you don't know how to take this stuff out, I better show you how to do that too. It's not super hard. In fact, it's very easy. So we're just going to unplug this electronics. We can shut off the radio now that we're done with that step. And then the first step, of course, is you got to get in here. They've taped down the leads just to kind of keep them from flopping around. And mine were taped a little bit further forward in my first one, so I didn't have quite as hard a time getting the tape off, but you just grab the tape out of there. That little black stuff is what come off of the bottom of Patrick's little stand. So we'll just stick that down somewhere out of the way. And then you can actually just reach in and unplug these three leads. Just doesn't matter which one's which. In my experience, they almost never line up color for color anyway. But if you were really curious about which one was which, then you could, you know, snap a picture of it or whatever, or write it down. Don't label it. It's a waste of your time. You're going to do this once, and then you're going to test it, and you're going to be done with it. And by the way, on this Volantex RC ESC, you can reverse the motor travel, if I recall, because I accidentally did it once. Not live. You have to go into the setup mode. So it's not like you can use it on a float plane and try to back taxi away from the edge of the shore. Okay. So now we're just going to pull this back down and through, and this will be a perfectly good ESC for something else, in my case. In your case, who knows what you're going to do with it. And sell it to somebody with an ASW-28 that doesn't want to use an aftermarket one. Okay. So there you have it. And now you can see what it looks like in here. That's what's inside there. And you can see it's nice and flat on this end. So that tells you that it's not an S-back or a U-back, it's just a regular BEC. And by the way, that would generally be indicated on there if it's got an S-back, but it just depends on the brand. Some are more proud of their stuff than others. So as you can see, we've got to go and either swap these connectors over. In my case, I'm just going to find something that's the same size and put those onto this end. And then I'm going to put an XT60 on this end. We'll go from there. Okay, so we need to make this YEP ESC look like this Volantex ESC for plugs, which should be pretty easy. The other thing I'm not real excited about is that these leads are quite a bit shorter than this. It shouldn't be a big issue, I hope. But, in fact, we might go look at that real quick. Guys, we're going to run out of memory here pretty soon. So I'll try my best to just probably splice it in and make this a one video thing. But as you can see, if you got your plug sticking out there, you're going to have to plug your battery in there, or you're going to have this ESC somewhere else. Now the thing that's nice about this ESC is it's quite a little bit smaller than the other one. You definitely want to try to have it where there's going to be some airflow. And you can see these leads here. You're not going to reach them unless you put this way down here, which should be fine. And then that gives you more room for other gear. So, but the trouble is if you end up putting your battery up there like we had considered earlier, then you might struggle to reach if you're not careful, okay? So just keep that all in mind as you make your decisions for how much room you're going to end up with, okay? So now that we've decided that it's going to be okay, we'll go ahead and run back in and get this soldered up. Okay, so I've got these bullet connectors, and I've just got male and female kit of an XT60. I happen to get those from Lemon, but not really anything too special. Just take the factory one, take one of the males and make sure it fits into the socket, which it does, and that will confirm our size. And then what we have to do is go ahead and get 3 of these soldered on, and that's super easy. The way I do it is I grab a pair of forceps and I actually hang on to the connector. I point it up. I get my soldering iron. This is a Weller 40-watt iron. It's very simple. Got a little tip cleaner. Got a little pad here for scratching the junk off of it, and then just a little bit of flux. Occasionally I'll dip that into the flux just to clean the tip. Looks like this tip might be a little bit bent over. I'll have to replace that soon. So what we got to do now is we'll go ahead and get some solder, just 4060 rosin core. Oh wait, this might be 44. It's called 44. It's made by Kessler or Kester. Okay, so we're just going to fill this thing up. You don't have to worry about putting the heat shrink on first because you can slide it over the top of this. Okay, so just kind of fill that cavity up real easy. These are already tinned. Get a little bit of heat on there. We're just going to wait till that solidifies. That's all she wrote. It's very simple to do that end. The XT60 is a little trickier because you got to get the heat shrink on there first. In this case, I'm probably going to go a little bit heavier with solder. We'll just redo that once. Oh shoot, you know what happened, guys? Look at this. I want to show you what happened. My solder overflowed and it ran down the side of the motor plug because the flux ran down the side. So not the end of the world, but it's a little bit annoying. So I'm actually going to hold this upside down and just heat it really hot and let that stuff drip down. Okay. Hate it when that happens. See, I'm holding it straight until it has a chance to set up. And that's what you do. It's very simple. Certainly didn't make it look very simple. Gosh, that is messy. So in this case, when you get a messy one like that, sometimes it's easier to just do it again and just put the one back into the bag, because you can use it again if you want, but maybe sometime you'll be doing a project you care less about. So same thing. That tip is pretty hot, by the way, just in case you're wondering, because it was being soldered right alongside the rest of the stuff. This time we'll just be a little bit more careful to keep it in there. And just kind of hold it steady, try not to move it around. And then we'll do the third one. That one's actually a pin. Now that's the other thing you can do, is you can hang on to the pin, and that'll give you a little bit more heat dissipation through the tool. So in this case, what I'm doing is I'm heating up the puddle, and then I'm letting that puddle transmit the heat into the wire. Problem is, it gets extremely hot on your fingers, and sometimes it gets to the point where you just got to let go. I got a little bit too hot there. The other thing is, sometimes it's nice to put something heavy on the end of those so they don't walk away from you. Okay, now I'm going to hold back just a little bit further on this one. Don't look very hot, but if it's a few hundred degrees on the tip of this, and then you get a really good contact with that solder, it's going to be probably about 180 degrees up here, I'm guessing, because I can't hardly keep my fingers on it. Okay. Just inspect your work. That looks horrible. Probably the worst job I've ever done. But anyway, I'll clean that up in a second. We'll get the XT60 on there. XT60 is a pretty straightforward process as well. Just cut the bag. In this case, we need the female end, but we're going to use the male end to hold on to that end. And actually, this is technically a male end because it's got pins, and then this is a female that's got sockets that would go on the battery. Okay, so we got a positive and negative, so we'll flip the ESC upside down, and that allows us to kind of keep our puddle on the right side of things. Okay, you'll notice that'll stick in there, but you don't want to stick that in there without having more exposed wire. So we're just going to strip a little bit of this back. Nothing too terribly difficult about that. Make sure you're satisfied with that. I want it to be all the way, so we can get as much contact area as possible. Get as much contact area now, and you'll just remove that one point of failure, because it's unlikely that you're going to lose that much contact area with a cold solder joint. Like if you get a bad joint, then it's kind of cheap insurance there. Alright, cool. So I can just stick that in there like that. Usually something heavy will work. Something heavy that's made of metal is kind of nice too. But 9 times out of 10 I just end up using my forceps to do this as well. Now obviously this isn't hooked to a battery, so you can grab both leads, but it's kind of a bad habit. You'll end up doing that accidentally while you're working on a battery someday. So you'll hang on to the lead like that, just one at a time, you know. It's probably the better option. So we'll bite that on there. We can tip this down and get ready to solder. But of course we need to get our heat shrink on here first. And the heat shrink, of course, red and black. Okay, so we got some heat shrink here. Part number for the red, part number for the black. I think it's 4mm. Might be mistaken on that though. So you don't need a lot, but you want it to be square, the end that goes up into the XT60. So this is where you can test for fit. Okay, that'll be a good fit. So we'll slide this on. It's not going to be quite that all the way out to the end. Some of it's going to be up inside the XT60. Okay, so I'm going to grab onto that a little bit different. First thing I'm going to do is I'm going to actually tin these wires. You see a couple of these individual strands got cut when I stripped it, which is not the end of the world. Come down here and then I'm going to let the solder soak into the wire. Wick into the wire. Sorry, no, it's not soaking. There's no soaking happening. So we'll just go pretty heavy on that until we see a nice big drip. And let the solder wick to the heat, okay? If you touch this spot here and it doesn't melt in, you're doing it wrong. You got to get more heat on it. Okay? So then if you have a giant glob, you have to knock it off. So just fling it if you want. Don't get it in your eyes. I'm sure that would hurt. Okay, so now what I'll usually do is I just take these now that they're freshly tinned and I'll slide them into the socket. Try to keep them straight if you can, meaning straight here. You don't want a big bend on them because that'll cause problems for you later. Got to clean the tip a little bit. Okay, so that's good. So now we're going to let that cool for just a second. It always seems like it takes a little bit longer to cool than I expect. Sometimes it'll catch off guard. Now remember, this is going to get hot, and then it's going to cool slowly. So as it cools back, just keep in mind you want to keep that heat shrink back so it doesn't shrink down before you can slide it over the connector. Okay, and if you ever have a big glob of solder like this, you can actually clip that off. Or you can heat it and melt it. But in this case, I just wanted to show you, you can clip it off. Okay, see I didn't clip enough of it off to get it in there smooth. And the other thing is there's a drip on the end, so you can also clip that off. Okay, see how that works? Now it goes all the way in. Okay, so this is the time where you'll get this to the position you want it to be when it's for its final state. So if you want that thing to be at a weird angle, you'll want to do it at this point. So there's not like a twist in this cable is what I mean, guys. Because that gets annoying to me. I don't know if I'm the only one that gets annoyed by that, but I get annoyed by that. So I'm clamping the second one on here to keep everything positioned right, okay? That's just holding it up. Dip, scrub, tip conditioner. And I'll use this tip to about 3 times as long as it should. Okay. Fill up the hole, let it wick in, put a little more if it's needed. Remember, you're trying to wick all the way up into this connector. I'm going to jump back over to black real quick and just fill that top up a little bit. Okay, cool. So now we're going to let that cool for a second. And at this point, you could get your heat shrink cut for the yellow. And I actually have yellow heat shrink, believe it or not, so I'm going to use the yellow heat shrink for those. A couple different sizes. Looks like this will probably be the right size for that. Here's the part number. It's just Hobby King. I'll make sure there's links to the stuff we're using, although I might forget about the heat shrink because it's such a menial thing. So guys, you get the idea. Basically this this project, I've said it before and I'll say it again, this ASW-28, it's just, I really like this plane, but it's a little bit of a project plane if you want to make it really work good. And guys, it's worth it. It's a good plane. It can be a good plane. I'm just surprised it wasn't making that, having that weird behavior with the ESC, because Esteban's actually had that problem too. So it wasn't just mine. It was my first one and then Esteban's, and then I just assumed this one would also have that same issue. Now remember, this is just cooling down here, but remember how we were having some extra solder come out? We're actually okay. That's not going to cause a problem. It's a little bit ugly. But now this has a chance to cool. You can actually take some of that off with the soldering iron if you wanted. I don't know if I care enough. It is extra weight. Solder is heavy. I mean, it's partially lead. Okay? So one thing you can do if you really want to make these things last a long time is you can take alcohol and a Q-tip. Okay? And what you can do is you can actually take and clean this. I don't always do this. I do it when I see that there's like unspent flux, because that acid can actually lead to corrosiveness or corrosion. And I think acids are corrosive, but anyway, once you clean that off, you just get the unnecessary flux, and you can see that gets yucky. Use the clean side. You can come from kind of nasty to nice and clean, and that's the time when you can go ahead and slide your heat shrink over. Plus it's nice and cool too after having that alcohol in there. That liquid alcohol is always nice and cool. Take your heat them down, and yeah, you can use the heat gun if you want. If you're into wasting a lot of time, that's a great idea. But I prefer lighters. It's easy, it's effective, gives you enough heat on the spot. You see, that's nice and sturdy, guys. Now over on this end, if you're going to leave this as is, the minimum you would do is you would take and clean off all this unspent flux. Okay? And you'll notice it's the brown stuff that burns on there. It's like oil residue almost. Sometimes you got to take like the backside of an X-Acto knife, and you can actually scrape that stuff off. Okay? But just be careful. Don't go too crazy, because you'll take the finish off of there too. So what I'm going to do in this case is I'm actually going to go ahead and take and grab back on with these straight forceps. One click holds them. I'll clean the tip, and I'm just going to take a little bit of this off. Just run that down like this. I don't like it looking messy. Okay, let it cool for a second. And then if you have a solder wick, like this desoldering braid, you can actually take that and clean it up real nice too. But I don't think I care enough to waste solder wick on this. Okay, so there's that. You got a nice smooth surface now, and this one just has barely any. But there's just once the flux runs down the side, then it'll kind of do what it feels like doing. So got that nice and cooled now. I'm going to take this one, went all the way down to the end. That was a bit of a bummer. You see, I've just got it upside down so that it'll run to the other side. Man, that thing is hot. Holy crappers. It's like burning my fingers. So you can see how hot it is by how quick it boils off the alcohol there. Okay, so simple as that, and then you can take your heat shrink and slip it over. I'm going to actually use a rag for this instead of a Q-tip, because I can get at it with a rag, get a little more abrasion on there. Alright guys, we'll come back with some more build video. We're going to probably wrap it up with this heat shrink, and then we'll be done. And we'll come back for some more. Use your finger to flatten that on there. Then we'll start mounting this stuff in there. Just keep working toward the finish goal. Okay, see, hold it, push it out. Ready to rock and roll. Just like that. If you have any sharp edges, you'll want to deal with those now. Don't wait until it's too late. Oop, I don't have a square end on there. So you gotta slide that on there. Pull it back, push it back into your fingertip. Gives you a nice clean end. Looks like the factory did it, except you had to waste all your time doing it. Who am I kidding? You're watching me do it, so. XT60 comes off. That can get put away. Unplug the soldering iron. And you're ready to come back and get this all installed. And what's really going on is my camera's about ready to run out of power. But it would be really nice if I could get one quick test before that happens, so you guys can see how the power consumption works with this. Alright guys, so we got the radio back on, throttle cut's on, got the battery in there, we got the new ESC in there, 30 amps with a 5.5 volt at 4 amp BS spec. Okay, makes a different noise, beeps a few times, ready to go. Oops, throttle cut's on. Throttle cut's off. Okay. Okay, so it's going the wrong way. Throttle cut's on. So the way you fix that, super easy. Of course, it's going the wrong way. I mean, why would it go the right way in this video? You just have to switch 2 of the leads. So I'm going to unplug the power, be on the safe side. Doesn't matter which ones, just unplug one. Unplug the other one, switch them around. It's really easy. Okay, so now that should change the direction, the orientation. Okay, so we're going to power this on, throttle cuts on, sticks down. Listening. Okay, throttle cuts off. Okay. 27.8 amps peak. See? It's already got braking on, guys. That's pretty sweet. I don't even have to mess with it. Okay. So our peak is 28.2 amps, and the maximum wattage, let's see what the maximum wattage is. Throttle cuts off. Looks like about 260 some. Inrush current. And it sags the voltage down pretty good. And if that happens when you're flying, it makes for a less than desirable experience. So let me grab that. Okay, so that is not typically a good thing to have happen. But it's just a bench test, so not probably the end of the world. Obviously, you'll want to tighten it more than I did. But with that, you understand where we're going. That's probably going to conclude the video for today. And this plane is going to be great, guys. It's going to be really good. And I think you're going to like it as much as I do. I'm sure you will. So I'm just going to figure out if maybe this didn't have a good bite. See, part of the problem is that this spins. This spins free. And so it does make it a little bit challenging to get on. Just whatever you're doing, don't hammer it on, because you'll regret doing that. Okay, so we'll get that on there. See, it spins, the whole mechanism spins, which makes it a little bit tricky to tighten. Okay, one more test. Okay, throttle cut is on. It's off now. I love it. It's going to be awesome, guys. See if I can give you a different angle of this without getting cut up. Let's do it here. Looks so cool. Alright, cool. That's about it, guys. Thanks for watching. Don't forget to like and subscribe. Check the links below. And you can help support the channel by buying the stuff through those links. Up next, we're going to go ahead and start some of the assembly. And we've got our receiver set up most of the way so that we can go ahead and center servos and good things like that. Come back for more of the Volantex ASW-28. Check the link below. Buy it from Banggood if you want. Help support our partners that sent this plane. Thanks for watching. Don't forget to like and subscribe.